Problem number 12. You guys just got to kind of try to play with the calculators and kind of think about what you're doing. So here we are asked to determine the domain. Now there are only two things that restrict the domain. Can somebody remind me of what those two things are? Square root's 1 and 0 in the denominator. So we have two rational expressions here, and I can't have a 0 in the denominator. So right off the bat, I know for a fact that x cannot equal 0 and that x cannot equal 3, right? Because if I plug in 3, I get 3 minus 3, and I get a 0 on the bottom there, right? All right, so I know that. Now how can it says to do this algebraically. I think that's pretty much it for the algebra, right? I mean, you could write it like this. Like you could say like x minus 3 cannot equal 0. Add 3 to both sides and get x cannot equal 3, right? And there's no square roots. And the second part is to do it graphically to kind of verify your results, right? And so let's graphically do this now and see what we come up with. So I'm just going to enter it into the calculator, 1 over x. Now I think you guys could do it, well, it depends. Some students prefer to do it graphically, some prefer to do it algebraically. There's a reason why the textbook wants you to do it both ways, and there's a reason Mr. Adams is being a stickler about following the directions in the textbook. The reason for this is when you take the ACT, you don't know what the answer is going to be. And one way to double check and make sure that your work is correct, because everybody makes mistakes, even Mr. Adams does, is to do it algebraically and then verify your results graphically. So if you learn how to do both, and you do both, and you get the right answer for both, you're pretty likely to have the correct answer. So I'm going to zoom out a little bit. We said it can't be 3 or negative 3, so I'm going to zoom out a little bit because it looks a little goofy. We'll do the standard zoom here. And sure enough, it looks like there's a vertical asymptote here at 3 and a vertical asymptote here at, a vertical asymptote at x equals 0 and at x equals 3. So now how do I write that in set interval notation? Well, let's look at the graph. All right, so I have x cannot equal 0, a vertical asymptote here, and x cannot equal 3, so I have another vertical asymptote here, okay? And to graph that, it looks like, I also have some horizontal asymptotes, but they're not talking about that now. But it looks sort of like this. This is what my graph looks like. Sort of. So how do I write that? Well, I just look at the graph. From here to here, I go from negative infinity in the x direction, right? Because this is negative infinity and this is positive infinity. To 0. Am I including the 0? Nope. Union. The next section goes from 0 to 3. Union 3 to positive infinity. Anybody have any questions on that? Now, where are you guys getting stuck with this, though? Is it the notation? Is it how to do it algebraically? Is it graphically? Or is it just having to do all three at once? Okay, well, that just comes with practice.